I am Branimir, and today I will be talking about the Bayesian network. I know that might not sound like the most thrilling topic, but at first, I believe some of you will find it quite interesting. For the beginning, just to memorize what is Bayesian theorem. Bayesian theorem is the element for the Bayesian networks, and the Bayesian theory say something about conditional probability. In Bayesian networks, we have nodes, like in all other networks, and all nodes are variables. And between these variables, there are some connection. We call this as edge. And that's everything what we can see. There are different probabilities. For instance, with soil variables, we can ask ourselves what's the connection, probability connection, so between soil type and soil moisture. For instance, that we know that the probability of specific soil type given the information about moisture content, for instance, clay soil retains moisture with 80% of probability, and the chance to soil is clay is 30. We know the sampling around where we have done sampling, the 30% are clay, and the 50% is chance that any soil retains moisture. Then we can, in a very easy way, calculate what is the chance that this sample would contain moisture is clay or not. Okay, let's start simple. At first, we see just two nodes and one edge representing a basic relationship like soil type influencing moisture. And actually, this is the true strength of Bayesian network. They allow us to model and analyze big systems with many interconnected variables. Each node represents a variable, and each edge shows how one variable influences. Actually, my motivation for making this lecture was that observing a lot of papers, I saw that many papers that use a Bayesian network in technology, in industry, in physics, but in biology and especially in soil biology, yes, there are not so much paper with Bayesian network, but I think that is wrong. Just short in history, the Bayes theorem, which formed the foundation of Bayesian networks, was introduced back in the 18th century. Despite its early discovery, the Bayesian method were underutilized. First reason for that was the loss of the calculating power. Now today, we have very powerful computers, and we are able to use Bayesian statistics. Bayesian statistics is quite older than Fisherian frequentistic statistics. Now, I would like to explain a case study in which we had access to a diverse set of measurement data, from which we selected the most abundant and homogeneous measurements. A total of 16 variables were measured across various soil types in whole Croatia at altitudes ranging from 25 to 780 meters. Actually, the data came only from soils classified as sandy, clay, and loamy. Actually, that was the data from different private companies that make a monitoring, official monitoring for the soil quality in Croatia. There was quite a few issues, best to say quite a lot of troubles with this data, because it doesn't come from a single well-planned study. this data was made from different companies, from different institutions, and were collected from various locations. And additional problem was that in some years, as you can see, 2014 or 2018, samples are missing or were of such poor quality that they couldn't be used for this research. But what we can do with such data, we can take approach. Our approach can be straightforward, and we can simply take all data, split it according to the well-known 70-30%, 70% for the training of neural network and 30% of the data for the validation, and train a neural network. And according to about 3,000 data, we can train the very good neural net, and that it was result. So we successfully used very simple neural net algorithms to create a reliable model for predicting both the likelihood of soil erosion and soil acidification. As you can see on the left side, the conclusion matrices on the left show high accuracy for both predictions, with the model achieving over 90% accuracy in both cases. That means that we can, according to this 16, that means 14 variables, estimate what is the chance that some location is under erosion or under acidification. But what we know else about these variables? Nothing. Although there are some possibilities to take out from the neural net model the weights of each variables. That means we can estimate how % of weighted or the weights in the neural networks is depends from each variable. So we can sort this variable according to the importance. But from this method, for any neural network method, we cannot, we have not insight in relationships between these variables. So what we can do forward? We can make a PCA analysis, for instance, and we done it. And as you can see, there are some strong correlated variables, but if you observe this first PC axis, this first PC axis describe less than 50% variance. That means that this data, from this data, we can not make some solid conclusion or conclude anything. But because of that, we have something what we call Bayesian network. According to this analysis, we can see, and according to the neural network with so high precision we developed, we can see that this data set contains a wealth of information. And a wealth of information, but with traditional statistical methods and neural network, we cannot find out this pattern in these variable connections. What we can do? Well, there are many powerful and advanced tools available in R and Python for building Bayesian network. Even the simplest one, this is this one, B&Learn package, enable to construct, we call the raw Bayesian network according to this data set. Why we call this raw Bayesian network? Because, as you can see, in this network, very often will be some illogical connections. For instance, you can see that according to this network, the composition is strongly depends from air temperature, not from soil temperature. Because of that, it's possible, but Bayesian network enable that, that we can reconstruct this network according our experience, according our knowledge, or according our previous research, or something else. On this slide, we see how the initial raw Bayesian network was modified to better address the specific research questions we had. Our research question was, what are the main variables that influence soil erosion and soil acidification? And these places on the edges are reserved for some statistics. And now you can see Bayesian network is developed according to the number of samples we used. In opposite to classical neural networks, any neural networks, the Bayesian networks can be very successful with a very relative small amount of samples. We started with 10 samples, and actually this is a simulation how this evolution of this Bayesian network could be in the case that it was used for the monitoring, when you have more and more samples. And what we can see, this slide shows how our Bayesian network looked when based on just 10 samples. At this stage, we can observe certain inconsistencies or illogical relationships, like in raw Bayesian network, such as a positive correlation between altitude and air temperature. That is because only 10 samples. But after about 3,000 samples, you can see that all connections are logical, and we expected, as we have expected. What we can do more? We decided in this step, we estimate what is a minimal sample size for stabilization of a Bayesian network. We concluded that it's the less than 1,000. With less than 1,000 samples, with less than 1,000 samples, we can stabilize our Bayesian network. And that was the beginning value for the next step. We decided to make so-called moving window through our old data to see what happened with Bayesian network, but with information what we obtained from Bayesian network in different time periods. And we make new simulation where the sample size is 1,000 for each step, and you can see the period, the years incorporate in this data what we have analyzed, and down average temperature in this period. And what did we discover in an interesting way using this method? Depending on the covered time period, the probabilistic relationships change, as well as the significance of individual variables. Take a look on this red arrow. That was the statistics for the several variables in period from 2003 to 2008. And in next period, from 2010 to 2015, these variables are changed. In the next period, the relationships, also we say probabilities relationships between variables stay unchangeable. And what is the difference between these two periods? Different is the average temperature. I must say that all samples was taken in May. And we see that this increase of temperature change some relations. So we can see that the higher temperature give a more importance to, for instance, deforestation and for some other variables. That you can see on this slide too. And on the end, what are the advantages and limitations for Bayesian and for classical networks? By Bayesian networks, they excel at uncovering causal relationship between variables and are great for handling missing data. If you have missing data, Bayesian network can help. They allow us to make probabilistic predictions based on conditional dependencies, which is particularly useful in understanding complex systems. To be open, the limitation, they struggle with capturing highly nonlinear relationships, which is why neural networks are often introduced as complementary tools. By neural network, we know that highly flexible in modeling nonlinear patterns in data is possible, and neural network can provide more precise risk quantification when dealing with large and diverse data sets. But neural network has limitation, lacks interpretability compared to the Bayesian network. And take-home message is that the combination of Bayesian network and any other neural networks enables in-depth interpretation of causal relationships thanks to Bayesian networks and more precise quantification and prediction of risk thanks to neural networks. Thank you for your attention, and I'm open for any question.